Okay, so we have a question here about how do we use prime factorization, like the prime factorization of radical 99, to help approximate the value of this number. And just to make it interesting, let's make it 3 radical 99. So the idea and the basis for this whole process is that if you take a number like, let's say, radical 16, and you think about 16 as a product of its factors, 4 times 4, right? 4 times 4 is 16, those are equal. The nice thing is that you can take the square root of both factors, square root of 4 and square root of 4, and then multiply them, and you'll still get the same value, right? This is 2 times 2, or 4, and that is the square root of 16. So you can do this thing where the square root of a number in terms of its factors a, b, equals the square root of a times the square root of b, or abc, or however many factors you have. So what we're doing here is we're going to look at 99 in terms of its factors. And we're going to use the prime factorization, right? It's 3 times 33, and this is 3 times 11. Just because, you don't have to do this, but I think it's useful. From the prime factors, we can find beautiful, perfect squares, and we can be sure to find them. So here, when I factor 99 to its prime factors, it's 3 times 3 times 11. Well, 3 times 3 is 9, and 9 times 11 is great because now we have at least one perfect square in there. So now we can break it down according to this formula. Radical 99 is equal to what? Well, radical 9 times 11. But I can take the square root of each of these individual factors and no, nothing will change. So radical 9, that's just 3. Radical 11, we can't touch that, but now we've got something easier to work with. So now this becomes 3 times 3 radical 11. All I did there was substitute 3 radical 11 for root 99, or radical 99. This 3 is still there, so that's why we're multiplying. 3 times 3 is 9, and we have 9 radical 11. So now we could approximate or truncate this value. We could have done it here from the start. There's no reason we couldn't have. But sometimes we had to simplify and also truncate. So you might as well simplify first before you find the approximate value or truncate. So going from here, where is radical 11? Well, it's between 3, right, and 4, because 3 squared is 9, and 4 squared is 16, and 11 is between those. So it's a nice proportional relationship. But we might want to approximate to a nearest tenth. And what I realized right away is that 11 is closer to 3 than 4, because 3 squared is 9, and 11 minus 9 is only 2, whereas 4 squared is 16, right? And 16 minus 11 is 5. So 11 is further from 16 than it is from 9, so 11 is closer to 3 than 4. So if it's closer to 3, I want to try values less than 3.5. I'll start with 3.3. Well, 3.3 squared, use the law of multiplication here. This is 9, 9, place over 9, 9. Just multiplied those out. We get 9, 18, and 10. So 3.3 is less than the square root of 11, right? Because 3.3 squared is only 10.89. What about 3.4 squared, right? What does this become? Well, let's work this out. Here, 4 times 4 is 16. 4 times 3 is 12. Plus 1 is 13. Placeholder. 3 times 4 is 12. 3 times 3 is 9. Plus 1 is 10. So we get 11, 5, 6. So this is larger than the square root of 11. So we've approximated it to the tenth place. It's between 3.3 and 3.4, but it's closer to 3.3 because 10.89 is only 0.11 away from 11, right? You can do the long subtraction, or just think how much do I have to add to this to get to the next whole number. Think 89 plus 11 is 100, just like 10.89 plus 0.11 leads you to the next whole number, which is 11. So the idea of all this is that now I'm going to use the square root of 11 as 3.3. It's the best approximation I can get to the 10th place. It's the closest value. So what do? Well, we simplify this to 9 radical 11, and now we have that radical 11 is 3.3, so now we just multiply, right? 9 radical 11 is almost the same as 9 times 3.3. And if we work this out, so our last step, we'll have our answer. 9 times 3 is 27. 9 times 3 is 27, plus 2 is 29. Placeholder, we get about 29.7, and that's our approximation. So we use the prime factorization to simplify this out, right? And that gave us this right here. Then we truncate, we're at radical 11. We find the decimal to some place value, and then use that number and multiply it by whatever else we have to get a good approximation. We could have done the same thing here, approximate radical 99, and then multiply that by 3. We would get about the same value. Doesn't matter which one we use. The idea is that you can simplify though before truncating, or do both. But just to be clear, you don't need to simplify in order to truncate, but it might help. So we have both strategies there for us to use. Thanks.